So hello everyone, this is lecture 65 for the mathematical physics. In the last lecture we have started some special functions and the first one was legendary, and we were discussing these plots for the legendary functions or the legendary polynomials, and we discussed up to here, and I gave you this little bit doubt here. So this formula was correct actually. Okay, so you can see if you put n equal to 1 here, so you can find p2 at 0. So when n equal to 1, it will give you minus, and it will be 1 here and 2 here, so minus 1 upon 2 it will give you. So see, for p2 at 0, x equal to 0, you will get minus 1 upon 2. Same for if you need to find p4 at 0, you will put n equal to 2 here, and 2 will give you here 3, and it will give you 2 to the 4, and here it will be plus 1, so it will be 4 into 2, and here it will be 4 minus 1, 3 into 1. So what you will get here, you will get 3 upon 8, because this is 4 into 2, 8. So again, at x equal to 0, this will give you 3 upon 8. So you are getting the same result. So this formula is very much right. So let's move forward. So today we'll discuss about the orthogonality and normalization of the legendary polynomials. So you must remember these properties because a lot question asked from here. So if it is your pnx and pmx some polynomial and nm, so this can be represented in this form: 2 Kronecker delta mn 2n plus 1. So you know what is the Kronecker delta property. If m and n are not equal, then this must be 0, and if m and n are equal, this should be 1. So if m and n are not equal, so this integration should be 0, and if they are equal, it will be 2 upon 2n plus 1 when m equal to n. So you can verify this result from the polynomials also. You can just multiply any two polynomials of legendary and take the integration. This will give you 0 if they are different. Okay, so just remember this is true result. So, and you can write this in terms of trigonometric ratios also. Let's assume x equal to cos theta when m equal to not n. So this must be 0. So x equal to cos theta will give you dx minus sin theta d theta. Now limit will be changed. For x equal to minus 1, theta will be pi, and for x equal to 1, theta will be 0. So it will be pi to 0, but because of this minus sign, limit will change 0 to pi. Then in place of x, write pn cos theta, pm cos theta, sin theta d theta equal to 0. Now you can see if you have any trigonometric functions in terms of cos theta, sin theta, and they are relating with the legendary polynomial, like pnx will give you x, like pnx equal to cos theta, and pm cos theta, this will give you second polynomial, and they are in multiplication. Then you can solve this using this thing. So that is the helpful result here. Now you must see these results. Based on this orthogonality, we can see that x dx can be written as 1 into x, and 1 is nothing but p naught x, and x is p1x. So these m and n are different, so this will be 0. And you can verify this. X square by 2 will give you 0 here. Same here, you can see this. It is p naught x 1 into this whole term. So p naught x multiplied p2x. This is p2x. So here m and n are not equal, so this must be 0. Now you can solve this, and you will get 0 again. So you can directly solve this using the help of legendary. Now see, this x square can be written as x into x, so it will be p1x. So now these m and n are same, so the result should be n will be 1, so 2 upon 3 should be your result. So it will be this. Now you can try to solve this. You can, using the integration, you will get the same result. Now 1 upon 4 3x square minus 1 square, so it can be written as p2x, because you know p2 is 1 upon 2 3x square minus 1. Now again result will be same, 2 upon 2 into 2 plus 1, 2 upon 5, because m and n are same. So that's how you can solve the integration using the help of legendary very easily. So let's see these two properties or more two properties. So here you have xm pnx dx, where m is less than n. If you have this kind of polynomial or this type of function, you can solve this. This will be 0 always when m is less than n. So let's take an example for this. It is x by 2 3x square minus 1. So see, this 3x square minus 1 divided by 2 is what? P2, and x has power 1, and that is less than this n. Now this must be 0 according to this, so you can directly write. So second one is, if power is same as the pnx, then the result will be 2n factorial divided by 2n plus 1 double factorial. So let's take the example for this also. X square by 2 3x square minus 1, so power is same. So now what you will do, you will just substitute in place of n 2. So it will be 2 into 2 4, and in divide you will get 2 to the 4 plus 1 5. So double factorial means 5 into 3 into 1, that will give you 15 here. So this will be your result. So must remember these results, very important. Now there is one more thing. Any polynomial can be written in terms of legendary series. So any polynomial you have can be written in terms of the legendary polynomials. How? Any function fx will be equal to a n pnx. it is like a naught p naught x plus a1 p1 x. If you have a quadratic equation x square something, so it will go up to p2, p1 p2, a naught p1 p naught p1 p2, and if you have cubic equation, then it will go up to p3. So that's how you will get, and you can calculate these coefficients a naught a1 a2 by this formula. An will be 2n plus 1 divided by 2 minus 1 to 1 fx pnx dx. So let's take an example for this. If you have fx in this type, alpha x square plus beta x plus gamma. Now this is a quadratic equation, so it will go up to p2. So a naught p naught x plus a1 p1 x plus a2 p2 x. Now you need to find these a naught a1 a2 because you know p naught p1 p2, but you don't know these a naught a1 a2. So you will use this formula. For a naught you will put n equal to 0. It will be 1 upon 2 p naught x fx dx. So this will be, and now p naught x is 1. So integrate this. It will be x cube by 3 here, x square by 2 here, and x here. So after putting the limit, this will become 0, and only these two terms will remain, and this will give you gamma plus alpha by 3. Now you have a naught. For a1 you need to put 1 here, so it will be 2 plus 1 3 by 2, and minus 1 to 1 alpha x square plus beta x plus gamma, and p1x is x, we know. Now you can solve this again, the simple integration. This will give you 0, this will give you 0, this will be only term remaining, and it will, in result, it will give you this beta. Sorry, you can solve this and you will get something here. So for the a2 we will substitute here. It will be 2 to the 4 plus 5 by 2, and p2 means here p2x fx dx, and it's a simple integration again. You know p2 value from the back side, you can check this, and this you will integrate simply and put the limits. This will give you 2 upon 3 alpha. So you can find these a naught a1 a2 a3, and then you just need to substitute here. Fx is a naught p naught x a1 p1 x a2 p2 x. So a naught is this gamma plus alpha by 3, and p naught is 1. Now this will be beta, means from here you will get beta. So beta and p1x is x plus this 2 upon 3 alpha is a this a2 it is, and p2x is 1 upon 2 3x square minus 1. So this will be your answer. This is multiplication. So that's how you can write any polynomial in terms of Legendre polynomials. So you must remember this method and this formula for the an. Now let's see the next function, that is Hermite function. So what is Hermite functions? So this is nothing but solutions of this differential equation. This is Hermite differential equation. D square y by dx square minus 2s dy by dx plus 2ny equal to 0, where n is greater than equal to 0. Now for different n you will get different solutions, and that solutions are called the Hermite polynomials or Hermite functions. So this is Hn x is the solution of this differential equation, just like the same as in the Legendre. Now there must be a generative function for this also. So for the Hermite we have a generative function which is gxt as e minus t square plus 2tx equal to Hnx divided by n factorial tn. Now see, here we can get our Hermite polynomials by comparing the coefficients of tn. So again we need to write this in terms of t terms, means coefficients. So how you can write? You know from Taylor series expansion, exponential x can be written in terms of x n divided by n factorial. It is 1 plus x over 1 factorial plus x square by 2 factorial, that's how. So we can write this e minus x as this, means this is your x, complete x, so it will be xn divided by n factorial. Now we'll use again the binomial expansion and solve these terms, and you will take the t terms out, means for the t and t square t cube you will take the coefficients out and compare with this tn here and n factorial is here. So that's how you will get your terms, and you will get these as your terms, means h naught x will be 1, h1x will be 2x, means for the t0 it will be 1, for t1 it will be 2x, for t square it will be 4 square minus 2, coefficients of this. So you can try to solve this and you will get the same results. So h2x will be 4 square minus 2, and h3x will be 8x cube minus 12x. So you must remember these three terms up to h3. So you must remember these polynomials for the Hermite up to 3. These are very useful. Now you must remember some special values also for this also, means what is the Hermite polynomial at 2n plus 1, means this will be odd. So see, all odd terms like this at 0 they are becoming 0 because the last power is 1 here. So that's why you get h2n plus 1 0 at 0 is 0. Now for what is for the even terms, means like this h2 h0 and h4. So this will be your formula. h2n at 0 will be minus 1 and 2n factorial divided by n factorial. Now see, you can find h2 at 0, means you need to put n equal to 1 here. So n equal to 1 will give you 2 over 1. So it will be minus 2 here from here. Now you can see h2 at 0. It will give you minus 2 here. So that's how you can find the term which is independent of x. So as this will give you h1 0, this 3 zeros, means all the odd terms will be 0 for the polynomial at 0. Now even terms you can find, h4 will be 12. So must remember this result also. Now as we did in the legendary, so we can find a relation between h minus x and hx also. So how you can find this? See from here, from this generating function, g minus x minus t should be equal to gxt, because if you put minus t here it will give you again same, and minus t minus x will give you again plus. So g minus x minus t should be equal to gxt. So you know gxt is hn x tn divided by n factorial. Now if it is minus x minus t, it will be hn minus x minus tn n factorial. Now you can compare the terms. From here you can take this minus 1 to the power n out and compare the coefficients of tn. It will be minus 1 to the n hn minus x divided by, means this should be equal to this hn x. Now from here you can find hn minus x should be equal to minus 1 n hn minus x. From here this is, and you can write this in their terms also, means hn minus x should be equal to, this will go into the right side, that will be minus 1 to the power n. So that will also be the result, same result. So that's how you can relate these two terms. Now let's see the recurrence relation in the Hermite. So you must know how to find the recurrence relation in the Hermite. So you just need to differentiate your generating function with respect to t and with respect to x. You can differentiate either way, you will get your some relation there definitely. So first let's do it for the t. So exponential minus t square plus 2tx with respect to time, it will give you not time, actually it's t only, sorry for that. So it will give you exponential, it will remain same, and it will give you minus 2t plus 2x. So this will be complete differentiation. In the right hand side you have this hn x tn divided by n factorial. So it will give you n tn minus 1 and tn minus 1 hn x divided by n factorial. Now this is equal to this. Let's multiply these two terms with this. So see, this is nothing but, this is again the same thing, hn x tn divided by n factorial. So when you do this, it will be tn plus 1 here. When you multiply this term, it will be t1 and tn here, so it will be tn plus 1. Means in place of this, you will write this only, hn x tn divided by n factorial, and multiply these two terms with it. So you will get these two terms here. Now this is equal to this whole. So now how can you find a relation? First we need to compare the terms of tn. So how you can do that? So make all these terms powers of t as n. So how you can make that? So in place of n plus 1 we can write n as n minus 1, so that will give you n. In place of n minus 1 we can write n as n plus 1, so it will give you n again. So let's substitute in place of n minus 1. So this will be turned out to be h n minus 1 factorial, and it will be minus 2 here, and here it will become tn as it is. Now here it will be n plus 1, so it will be n plus 1 factorial, n plus 1 hn plus 1, and this will be tn. Then after comparing the coefficients we will get this relation, and this will remain as it is, and n factorial can be written as n minus 1 factorial. So it will be 2x hn x and n minus 1 factorial. Now see here, you can just remove this term n minus 1 factorial, because this is common in all the terms. So when it will be n plus 1, it can be written as n plus 1 and n minus 1 factorial. So this term will be removed, and it is a simple calculation. Then it can be written as 2x hn x minus 2n hn minus 1 x equal to hn plus 1 x, and this is your recurrence relation. And you can verify this result how? Means you can just put n equal to 1 here, and it will give you 0 or 1 here and 2 here. So just substitute value for h0 and h1 and check for h2 if you are getting the same result or not, as you already know. So that's how you can verify if in any question the recurrence relations are given. So that's how you can verify the recurrence relation. So let's see one more relation. So let's this time let's differentiate with respect to x. So e minus t square plus 2tx equal to, so it will give you exponential same, and it will give you here 2t. So it will be equal to, now hn x will give you hn dash x, and tn by n factorial will remain as it is. So this is your equation. Now you need to again compare the values for tn. So this is again same term. From here you can see hn x tn divided by n factorial. So it will be 2, and t will give you n plus 1 here. Now you need to compare this with this. So you need to first make this value tn. So how you can do that? Just substitute n in place of n minus 1. So it will give you n again, and here you have n already. So now it will be h n minus 1x n minus 1 factorial, and that will be equal to this term. So now see, this n factorial can be written as n minus 1 factorial, and this will cancel out, and you will get this relation 2n hn minus 1x equal to hn dash x. Now see, this is also a recurrence relation, so you must know how to get these recurrence relation and how to differentiate. So this is the basic method you must know to solve any question. So that's all for today. Thank you everyone.